Sorry, let me turn off the blow dryer. Right, so today I want to talk about artificial intelligence systems, what they could do, what they can't do. A lot of people are using them for a lot of decision making, and to be honest, there's some serious major limitations that people are ignoring when they use LLMs. One of the things that I think is really clear about LLMs is that they're dumb as fuck. But they look really smart. And so the first time you use it, you're like, wow, this is really impressive. But I mean, if you keep using it, you eventually find a place where it makes really, really poor decisions. So for example, ask it simple questions like, hey, I want to wash my truck at the car wash. It's 300 meters away. Should I walk or should I drive? And ask it a couple times and see how many times it tells you to walk versus drive. Because I've asked a lot of the different models, and the smarter models tend to say, hey, walk. It's really good for the environment. But then I don't have my truck at the car wash, and so how am I going to do that? Those are the types of simple errors in the reasoning that it makes. And a lot of times people think it's because it's making errors in reasoning. And that assumption is flawed. It doesn't actually reason. And so I think understanding the underlying architecture behind an LLM model and what it does, I think is really important, because most people that use LLMs don't understand that technology. So there's a few good resources that go into it, but I'm going to just give you like a really simple, basic description of the underlying principles that guide an LLM model so you can maybe have a chance to understand it. Odds are that I'll explain it in a poor way or incorrect way, and someone will correct me. Thank you, whoever does that. But basically, think about an LLM as a magic pointing device that likes to point at different pieces of information. And if you tell it, hey, can you point to something for me? It will. But instead of just being like one person pointing and say, hey, how do I cross the road? And it points over there to cross the road. Instead of being that simplified, it's 96 different layers of pointers with tons of different things, every single different token or every different word in that system pointing. And they all have a different pointing measurement going in different directions. They have a different amplitude. They have a different vector towards a different part of that vector space. Ignore all of that. So it's basically just a bunch of little things pointing at different things. And you give it a bunch of input. You say, hey, I want you to think about all these words together. Look at these words in this bundle that I gave you in a chat. It says, hey, okay, all those words, if I put them together and I see where they're pointing, they point over there, right? They tell me to look over there. And because I'm looking over there, the things over there are words like this. To give you a really good example, ask any of the LLMs that you use, choose a random number between 1 and 10. And it'll say, hey, all those words triggered pointing in my brain. It says, I want to look over there. I want to look over by the random number section. I want to look over by the 1 through 10 section. I want to look over like the favorite number section. And it's going to tell you 7, because all those things point to 7 in its space. Once it's pointed to 7, then it's going to draw a line back from 7 to your question. And it's going to say, let's fill in the gaps. 7's my favorite number. Why? And it'll kind of explain it all the way back to you. So it's kind of like the way lightning strikes. Is the first strike isn't just a directional strike. It first forms a kind of electrical connection, and then the current goes through. So I think LLMs are operating in a similar principle, where it points to the answer, and then it works backwards from the answer to reconnect it all the way to you and fill in the gaps. And because of that, it feels like there's a lot of reasoning and logic going on behind it. But fundamentally, there's really just one answer with no reasoning or logic, and then it works backwards to get to you, which is kind of the opposite of what we think of when we think about reasoning. For another example, you can try, if you want to, ask any of the LLMs that you use to do this sequentially, and do this in a single chant, right? So do this sequentially. Choose a random number between 1 and 10. Divide that number by 2. That's how many limbs the animal has. What animal is it? Odds are, when you send that, depending on which LLM you use, you'll get something like a red fox, a dog, or a starfish if you use a very specific model, right? You don't always get that because there is a little bit of randomness when it comes to LLMs, but you do consistently get it to show you, here's the answer I want, and let me work backwards to get to you. And it says that it's doing the opposite. It says, oh, I chose a random number 8. I divided by 2. I got 4 legs. 4 legs is a common tetrapod. It's probably going to be a dog. But it didn't start with tetrapod. It didn't start with 8 divided by 2, because how else would it choose 8 divided by 2 every single time that I've done this experiment? I mean, well, 80%, 90% of the time. But it chose dog, and it worked backwards from there. Or if it's Gemini, it chose red fox, and it worked backwards from there. So AI is answering questions in a way that looks like it's making decisions without actually making those decisions. And that's why you have this weird uncanny valley when you read AI and it says, here's this answer. This is one of those really specific historical phenomena that's known as, and it makes up some random explanation or story that doesn't make any sense because it doesn't make any sense. But it has to connect the two. It has to connect you back to the vector space that it was pointing at. And that's how it forms the chat communication to be able to explain rational and reasoning and line of thought. So to start with that, hopefully that kind of explains why AI feels weird when you ask it simple questions that require rational processing or chain of thought decision making. There's been a few different strategies that help with chain of thought. One of them is to literally just say, hey, work through this sequentially, do this slowly, think carefully. Because when you say that, it points to areas of its vector space where logic and reason have more weight. So it uses more of the weight from those types of explanations and systems, and then it's more likely to come up with the right answer. It's still not reasoning, it's still not rationing through that. It's just pointing to areas of its brain where it has more rationalization information integrated into the weight system. Hope that made sense. Probably didn't. Good luck figuring out it. AI is really neat. I'll do more videos. Maybe. Thanks. Bye.